Good day everyone, welcome to the world of mathematics. So in this video, we will learn important things and those are about pre-calculus and basic calculus. So math is not that hard actually, so don't be discouraged or confused right away because I am here. Teacher Ella will help you understand each lesson in this subject. So without further ado, let's start our discussion.
So for our lesson for today, it's all about distance formula. So Frederick L.W.M said, it takes both sides to build a bridge. Though sometimes we need to give the distance to others to respect them, there are also times that we need to have connection with others and work cooperatively, and it will give better solutions and new ideas. Indeed, we should always look for ways to build a good relationship. So for the objectives for today, we have first one is to derive distance formula from Pythagorean theorem. Second one is to solve real life problems involving distance. And last is show patience in solving real life problems. To formally start our discussion, let's have this problem. So the beam of the lighthouse can be seen for up to 12 miles. A certain fishing vessel is located at 3 miles east and 5 miles north, while the ship is located at 10 miles east and 12 miles north. So we have here 4 questions. One is, what is the radius of the beam of the lighthouse? 2 is, does the beam of the lighthouse can be seen from the location of the fishing vessel? Why or why not? Third one is, does the beam of the light can be seen from the location of the ship? Why or why not? And last is, how far is the fishing vessel to the ship? Okay, so each question we will explain the solution if it has, and also we will come up with the final answer. So let's have the first one. So what is the radius of the beam of the lighthouse? So for this question, it's easy since the radius is clearly stated in the problem, in which, again, according to the problem, it has the radius of 12 miles. So that's the answer already in question number 1. Now, let's proceed to question number 2. So question number 2 is, does the beam of the light can be seen from the location of the fishing vessel? Why or why not? Okay. So first is, we need to recall the Cartesian plane. So why Cartesian plane? So in this, we can easily visualize where is the location of the fishing vessel, because according to the problem, the fishing vessel is located at 3 miles east and 5 miles north. So we will use the map here. So let's say, for example, again, the lighthouse is located at the center of the origin, or this one, the 0, 0. Then we will find the 3 miles east and 5 miles north in the Cartesian plane. So when we say east, that is going to the right side. So we will count 3. So 1, 2, 3. Then after that, 5 miles north. So going up. So we will count 5. So from this one, we will count 5. 1, 2, 3, 4, 5. So this is the location of our fishing vessel. Okay? That is 3, 5. Now, next is, we need to determine what is the distance between the fishing vessel to the lighthouse, which is located at the center of our Cartesian plane. So for us to know the distance is we can create a triangle or right triangle. So through that, we can solve this one by simply using the Pythagorean theorem since we created right triangle. So we have our A, which is 3 miles. Our B is 5 miles. And our C is the missing one, which is the hypotenuse of our right triangle. So again, to recall the Pythagorean theorem, we have here the formula, which is c square is equal to a square plus b square. So we will just substitute the given a and the given b in the formula. So copy lang natin si c square. Then after that, substitute a. So we have our a 3. So 3. Then don't forget to copy also the exponent. So we have 3 square plus the value of b, which is again 5, and our exponent 2. Okay? Then after that, simplify. So 3 square is 9, 5 square is 25. Then after that, add. So we have 34 as c square. Now, we need to find the value of c, not the c square. So to eradicate the square, we need to find the square root. Okay? So since we find the square root of the left side, the same with the right side. Okay? So c square, the square root of that is c. And also, using your calculator, you can find the approximate value of square root of 34, which is approximately 5.83. Then again, don't forget the unit or the units in solving problems. Okay, so the final answer here is the fishing vessel is still in the radius of the lighthouse. Okay, so meaning in the location of the fishing vessel, they can see the beam of the lighthouse because again, the location of the fishing vessel is located at 5.83 miles. Okay, so this is under the radius pa rin. Now, let's proceed to the distance formula, which is our lesson for today. So in distance formula is we have, as you can see, we have also formula. Okay, so we have d, that stands for the distance, equals square root of the quantity of x sub 2 minus x sub 1 square plus the quantity of y sub 2 minus y sub 1 square. So this is y sub 1. This is a typographical error. So this is y sub 1. Okay? Then the square. Next one is, again, the first ordered pair is the 0, comma 0. Why 0, comma 0? This is the location of our lighthouse. So it is located at the center. So 0, 0. Now we will use the second pair, which is the location of our fishing vessel, which is 3, comma 5. Now, for you um, to easily find the x sub 2, x sub 1, just put x sub 2, x sub 1, or y sub 2, y sub 1 in the given ordered pair. Okay? So since this is the first ordered pair, this is the x sub 1, and this is the y sub 1. Then for the second pair, we have x sub 2 and y sub 2. Okay? Then after that, after determining which is x sub 1, x sub 2, y sub 1, y sub 2, substitute it to the formula. Okay? So we have, again, our x sub 2 is 3. Our x sub 1 is 0. So minus 0. Then copy the square plus y sub 2, which is again this one, 5, minus our y sub 1, which is 0. Then again, don't forget the exponent. Then after that, we will simplify um, the inside of the parentheses. So 3 minus 0 is 3, and 5 minus 0 is 5. Then after that, we will simplify 3 square and 5 square. So 3 times 3 is 9. 5 times 5 is 25. Then add, we have 34. So we have 34 or square root of 34. So to determine the exact or the approximate value of that, again, we will use the calculator. So the distance here is 5.83095 or approximately 5.83 miles. Okay. So the distance formula is a variant of the Pythagorean theorem. So in short, distance formula is a formalization of the Pythagorean theorem using x and y coordinates. So like earlier, again, we have x sub 1, y sub 1, x sub 2, y sub 2 that is needed in the formula for the distance formula. Okay? So from the Pythagorean theorem again, which is C. Okay, so this is C square. We have typographical again. So C square equals square root of A square plus B square and become the distance formula. So again, we have square root of x sub 2 minus x sub 1 square plus y sub 2 minus y sub 1 square. Okay, so again, this is the formula in getting the distance between the 2 points. So let's have the question number 3. So thus the beam of the light can be seen from the location of the shape. Why or why not? So same process with question number 2. We need to have the Cartesian plane for us to determine the location, to visualize the location. So we need to plot our coordinate, which is, according to the problem, the ship is located at 10 miles east and 12 miles north. So meaning our um, x here is 10 and our y is 12. So therefore, here is the location, or this is how we plot our ship's location. This is 10, 12. Now, using the point or the location of the shape, we can create again the right triangle, which is our A here is 10 and our B is 12. Then we need to find the hypotenuse of our triangle or the C. So we can use first the Pythagorean theorem, like question number 2. So Pythagorean theorem is again c square equals a square plus b square. So we will just substitute the given. So our a is again 10 and our b is 12. So we have 10 square plus 12 square. Simplify. 10 square is 100 or 10 times 10 is 100 and 12 square is 144. Add them up, we have 244. Again, we need to find the value of C. So we need to find the square root of both sides to determine the value of C. So square root of C square is C. And again, using the calculator, the square root of 244 is approximately 15.62 miles. Now, again, the question is, does the beam of the light can be seen from the location of the ship? And again, the location is 15.62 miles. So the answer is the ship is not in the radius of the lighthouse anymore, because its distance from the lighthouse is again approximately 15.62 miles. And the radius, according to the problem, the radius of the beam of the lighthouse is only 12 miles. So I hope you understand this question or this answer for number 3. Now let's proceed to let's proceed to the computation using the distance formula. Again, the distance formula is this equal to square root of the quantity of x sub 2 minus x sub 1 square plus y sub 2 minus y sub 1 square. Again, our first ordered pair is the location of our lighthouse. And the second ordered pair is the location of our ship. Substitute. Again, this is our x sub 1. This is our x sub 2. Or sorry, this is our x sub 1. This is y sub 1. Sorry for that. And 10 is our x sub 1. And 12 is our y sub 2. Okay? Substitute. So x sub 2 is 10 and 0 is the x sub 1 plus 12 is our y sub 2, then our y sub 1 is 0. So simplify. 10 minus 0 is 10. 12 minus 0 is 12. Then after that, simplify 10 square and 12 square. We have 100 and 144. So add them up, we have 244. Then we will find the approximate value of square root of 244 by using our calculator. So therefore, the distance is again 15.62 miles. Okay? Let's have let's have question number 4. So we need to plot here the location of the fishing vessel and the ship. We need to find the distance between the 2 points. Again, the fishing vessel is 3, 5, while the ship is 10, 12. So we need to find the distance between the two. So let's just explain the answer, or how did we come up with 9.90 miles. So again, using the distance formula, this is our x sub 1, y sub 1. This is our x sub 2 and y sub 2. So we have, again, x sub 2 is 10 minus our x sub 1, 3. Then after that, substitute also the y sub 2, so that is 12, minus the y sub 1, which is 5. Next is simplify. So 10 minus 3 is 7. Then 12 minus 5 is 7 also. Then after that, simplify. 7 square is 49. 7 square is 49 again. Okay? Add. We have 98. So we need to find the approximate value of square root of 98. So again, using the calculator, this is approximately 9.90 miles. So that's the answer. That's the distance between the fishing vessel and the ship. Okay, so let's have another examples. Example 1 is find the distance between the 2 points. We have x sub 1, which is 8, y sub 1, 3, and we have x sub 2, 9, y sub 2, 9, right? So always remember the x sub 1, y sub 1, x sub 2, y sub 2. So using the distance formula, substitute. Again, x sub 2 is 9 minus the x sub 1, 8, then square plus our y sub 2. So we have 9 and our y sub 1, which is 3. So let's simplify. 9 minus 8 is 1. Then 9 minus 3 is 6. Next is 1 square is 1. 6 square is 36. So 36 plus 1, we have 37. Again, we will use the calculator to find the approximate value. So we have 6.8 units. So that's the answer already. That's the distance between the ordered pair 8, 3 and 9, 9. Next one. Find the radius of a circle given that the center is at 1, negative 5 and the point negative 1, negative 3 lies on the circle. So in this problem, we have the given center and we also have the given point. So all we need to do is we will use also the distance formula to find the radius. So again, this is our x sub 1, this is our y sub 1, x sub 2, y sub 2. Substitute y sub 2 or sorry, x sub 2 is negative 1, x sub 1 is 1. So minus 1, then square, plus our y sub 2 is negative 3, then minus our y sub 1, which is negative 5, then our square or our exponent. Next is simplify. So negative 1 minus 1, that is negative 2. Okay? So negative 2 square plus, we have here negative 3 minus negative 5. So negative 3 minus negative 5, the answer is positive 2. Then simplify. Negative 2 square is 4 and 2 square is still 4. Add, we have 8 or square root of 8. So again, using the calculator, the approximate value or the approximate radius of the given circle is 2.83 units. So that's the answer or that's the radius. So that's all for today. Thank you for listening.
Hopefully, you really understand our today's lesson. So don't forget to practice more so that you can fully understand our today's lesson. And also, don't forget to attend your synchronous class for more examples and real life problems about our topic for today. So thank you for listening and see you on the next video. Bye!